Warm greetings to all. In this video, we are going to see about shift registers. A register is a device which is used to store such information. It is a group of flip-flop connected in series used to store multiple bits of data. An n-bit register has a group of n flip-flop and some logic gates and is capable of storing n bits of information. The function of registers are retrieving data from register, store or load new data into register, shift the data within register either left or right. Shift registers are registers that allow binary data to move from one flip-flop to another within the register. The data can be moved within or in and out of the registers using clock pulses. Shift registers are a group of flip-flops connected in a chain so that the output from one flip-flop becomes the input of the next flip-flop. The different types of shift registers are serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out, bidirectional shift register and universal shift register. The shift register, which allows serial input and produces serial output, is known as serial in, serial out shift register. The block diagram of serial in, serial out is shown here. Initially, all the flip-flop are set in reset condition. That is, output Q3 is equivalent to Q2 is equivalent to Q1 equal to Q0 equal to 0. If we pass the binary number 1111, the LSB bit of the number is applied first to the D-in bit. The input of flip-flop 3 is directly connected to the serial data input. The output of F of 3 is passed to the data input D2 of the next flip-flop. This process remains the same for the remaining flip-flops. Now let us see the operation of this shift register. Step number 1. When the clock signal application is disabled, the output Q3, Q2, Q1, Q0 is equivalent to 0, 0, 0, 0. The LSB bit of the number is passed to the data input D-in, that is D3. When the clock is applied, the value of D3 becomes 1. The flip-flop F of 3 is set and the word is stored in the register at the first falling edge of the clock. Now the stored word is 1000. Step number 2. For the next clock pulse, the output of the flip-flop F of 3 is given as the input to the next flip-flop F of 2. And the next bit of the binary number, that is 1, is passed to the data input D3. The flip-flop F of 2 is set and the word is stored when the negative edge of the clock hits. The stored word is changed to 1100. Step number 3. When the next clock pulse hits, the output of the flip-flop F of 2 is given as the input to the next flip-flop F of 1. Output of F of 3 is given as input to F of 2 and the next bit of the binary number, that is 1, is passed to the data input D3. The flip-flop F of 1 is set and the word is stored when the negative edge of the clock hits. The stored word is changed to 1110. Step number 4. For the next clock pulse, the output of the flip-flop f of 1 is given as the input to the next flip-flop f of 0. Output of f of 2 is given as input to f of 1, f of 3 to f of 2, and the next bit of the binary number, that is 1, is passed to the data input T3. The last flip-flop, that is flip-flop 0, is set and the word is stored when the clock's negative edge arrives. The stored word is changed to 1111. The truth table for serial in, serial out shift register is shown here. The different applications of shift registers are delay line, serial to parallel converter, parallel to serial converter, ring counter, twisted ring counter, and sequence generator. Thank you.